All right, let's do this. Next week, you got Wednesday, Thursday. I think I scheduled the quiz for. All right, Wednesday, Thursday. I'm still thinking about it, about doing it just one day. All right, anybody who's here takes it on paper. Anybody at home just takes it on formative. All right, so I'm thinking about that. I haven't set in stone. The only reason I'm thinking about it is it's one less day you got to watch a video if you're not taking it. All right, and I like to actually teach you the stuff and not have you watch a video instead. But I'll think about it. All right, I enjoyed yesterday a lot. All right, hopefully you guys had a nice break from the grind of notes every day and actually picked up how to use Pythagorean theorem on the honors geometry level. One thing I did notice that maybe I wouldn't have noticed if we took a day to practice is let's make sure we got something like this figured out, okay? Let's make sure we got something like that figured out if I have that in a problem and I got to expand it. It's not x squared plus 4. Again, I need to make sure I multiply by itself twice and then do a little double distribution with it. All right, so that's one big thing I picked up yesterday. All right, so a couple of you guys be aware of that because I believe there is a question on next week's quiz that you're going to have to take care of something like that as part of the problem. So watch out. All right, so just a quick recap where we are in this unit. Quickly, name of this unit again is what? Everything on what? Right triangles. Everything we need on right triangles. So day 1, day 2, I gave you a right triangle, and then I drew an altitude in, right? Coming from a right angle. So if I draw an altitude in coming from a right angle, and now I have 3 right triangles, what's starting to go in our head right now? If I have this diagram, this specific scenario I give you guys, what's going in your head? Probably can use what? Oh. Hills and Sass, yes. Altitude from the right angle. I can use Hills and Sass. And also keep in your back pocket, since you do have 3 right triangles, Pythag always an option. All right. And then yesterday and the day before, we talked, hey, there's a lot of different ways I can use Pythagorean theorem other than solving for a side, right? You could tell if the triangle is obtuse, acute, or right. So that's another option we had for Pythag. Moving on. Today, what else can we do with the right triangle? Oh, we got a lot more in store. What's going to happen today is you're going to deal with the right triangle where the other 2 acute angles are 45 and 45 degrees. You're going to know a special pattern happens if that type of triangle comes up, 45, 45, and a 90. Then after we get good at that today, I'm going to give you another right triangle, but now the acute angles will be 30 and 60 degrees. And there's a real pattern between all the sides in a 30 and 60, 90 degree triangle. So that's our goal today. We're going to work with these 2 special right triangles. Let's start with the 45, 45 on your notes. All right. If you read the beginning, I'm like, hey, they're isosceles right triangles. Quickly, isosceles, anybody fill me in? Isosceles? I'm new to this geometry game. Isosceles triangle? 2 congruent sides. And if it's in a right triangle, what do you think those 2 congruent sides are? The legs. Correct. In an isosceles triangle, so if I take this first triangle here, that's got BC as 1, it's isosceles, so I know the legs are equal. So I already know AB has to be 1. The legs in an isosceles right triangle are equal. Okay, kids, anybody got a method on how to find AC, the hypotenuse? Hey, what the heck have we been doing all unit? Pythag, go. Simplest radical form. Find AC using Pythag now in that first triangle. Shouldn't take you too long on this one. Go ahead, Pythagorean theorem. AC should be equal to, here we go, 2, 1. Let's start it off. Zach, what's AC going to be equal to if you use Pythag?
Radical 2.
Radical 2, done. All right, 1, 1, radical 2. All right, you guys have 2 more triangles. Find the other sides of those triangles, please. You already know the legs are equal. They're isosceles right. So the finding one missing side should be pretty easy. Then do pi-fag to find the hypotenuse. And let's see if we come up with patterns at all. Again, simplest radical form. You will not see the pattern unless your radical is broken down. Simplest radical form. All right, looks good. Hypotenuse on the second triangle. And then, hey, guys, don't wait here. Look at your triangles right now. See if you see a pattern as I'm going over this with a couple people. Ryan, here you go. What's AC? Hypotenuse AC in the second one.
2 square root of 2.
2 radical 2. Good. 2 radical 2. And I put that in gray for a reason, so I can put that in gray. 2 radical 2. Third triangle. What's hypotenuse AC in the third triangle? Let's talk. 18. Owen, what do you have for that last triangle? Hypotenuse.
3 radical 6.
Radical 6? Where'd 6 come from? You got 18, right? Square root of 18?
Yeah.
All right, what 18 break down into? Not 6 and 3, because those aren't perfect squares. I need a perfect square that goes into 18. What's a perfect square? What's that? Go ahead, sorry.
3 radical 2.
3 radical 2, because you got 9 and 2, 3 radical 2. All right, there you go. 3 radical 2. Questions there? Everyone see a pattern between the sides on a 45-45? All right, got to explain to me what the pattern is. Let's say I know one of the legs. Let's say I know one of the legs. How do you always get to the hypotenuse very quickly? I do not need to do Pythagorean theorem anymore. Omni, go ahead.
Just like put radical 2 next to it.
That's not very mathematical.
Well,
What operation am I doing with the radical 2? Just not putting it next to it, but
I feel like
multiply the leg by radical 2. Everyone's good? Multiply the leg by radical 2. So in the conclusion here, here's what we're going to write here. In a 45, 45, 90. Everyone okay on it? Why I'm calling it a 45, 45, 90? Because, right, those are the degree measures. All right, in a 45, 45, 90 triangle. I'm just, to make it easy on you guys, I'm going to set up a chart here. One column will be 45, one column will be 45, the third column will be 90. What do you guys know about the sides across from the 45? What did we just find out? The sides across from the 45? Always the same. Now they're different problem, right? The values are different problem to problem, but they'll always be the same length. So I'm going to put X and X inside the chart underneath the 45. Again, I'm talking about the sides across from the 45s are always equal. And then Omni, going back to you, what do I do with one of the legs to get to the hypotenuse?
you multiply it by radical 2.
Okay, so here I'm going to put X times radical 2. That's what I do to get to the hypotenuse. All right. Now, from time to time, I'm going to break out this chart, but I think for the 45, 45, 90, the legs are equal, multiply it by radical 2 to get to the hypotenuse.
That's
Oh.
So if we're just given enough information that 45, 45, and 90, can we assume that it's right across these triangles?
It's got to be.
I mean,
2 angles are the same, and you got a right angle. Right?
Yeah, right.
So, yeah, you can. No assuming needed, though. We know for a fact. We're all good? All right, let's actually use some values here. So I got angle A is 45. It's a right triangle, as you guys can see. I'm just going to call angle C my right angle. Angle A is 45. BC is 18. Can you guys find the other two sides? I don't have time for Pythag anymore. Today, anyway. If you want to do that on your own tomorrow when we practice, that's fine. I got no time for Pythag. All right, here we go. 7, St. John. What's the other leg? AC here.
18.
Also 18. Legs are always equal in a 45, 45. And then St. John, what do I have to do with one of those legs to get to hypotenuse AB?
Multiply by radical 2.
Yep, so 18 times radical 2. There's not much more I can do there. No issues? That's pretty basic. All good. Any questions? All right, let me change it up on you now. Let me give you a different piece of the triangle. Same triangle, angle A still 45. No issues there. Now I'm going to give you the hypotenuse. Is 17 radical 2. Oh, I gave you the hypotenuse now. I gave you the hypotenuse. So usually to get there, St. John just said, hey, multiply by radical 2. So if I want to go backwards, what do you think I do with the hypotenuse now? Usually to go from the leg to the hypotenuse, and you don't have to write this, leg to hypotenuse, I multiply radical 2. What do you think if I want to go backwards, kids? What if I want to go backwards? Instead of multiplying, divide by radical 2, yeah. And I know you don't need to do that here because you guys can see the pattern already, but that's what would happen if I wanted to go backwards. If I knew the hypotenuse, divide both sides, divide it by radical 2. All right, what's AC and BC then here? It's the value of AC and BC. Going backwards now on you. 13, here you go, Sophia.
And this is on number 2, sorry.
Yep.
17.
17, done. And if you want to see where that came from, 17 radical 2 divided by radical 2. Goodbye. You get your 17. Questions before I get a little nuts now? All right, let's get nuts. BC, 11 radical 2. Find AB, find the hypotenuse now. All right, don't get freaked out. Remember the pattern. What do I do with the leg, which I'm given? 11 radical 2 is the leg. What do I do with that leg to get to the hypotenuse? I don't care what it says. I don't care what it says. What have you guys been telling me all class to go from the leg to the hypotenuse in a 45, 45, 90? Oh, deep. Sabrina, what have we been doing to the leg to get to the hypotenuse? Correct. So ready, guys? Take the leg, multiply it by radical 2. Uh-oh. Oh, boy. Yikes. Yikes. How do I do that? Well, you could use your calculator if you wanted to, but before you pick up your calculator to do it, let me show you how to do it algebraically without having somebody do it for you. Ready, kids? 11. And I think we've done this enough. Anybody remember when you multiply a radical by itself?
Oh, it's just 2.
Radical 2 times itself. What ends up happening? You get the number underneath the radical. So times 2. So this will be 22. And again, if you're not confident, and I wouldn't be yet, we haven't done enough of these problems, but again, you can just say 11 radical, fat fingers, 11 radical 2 times radical 2. There you go. All right. You guys have any questions? Please ask, because this is the easier of the two. Sophia.
Can we get a point where we have to multiply something like radical?
Tomorrow, not tomorrow, Friday, correct.
Right.
So what if CB was 11 radical 6? Yes, we will get to that point starting on Friday, day 2 of all this. That's when the hardcore radical algebra comes in, yes. I need you guys to know the basics though first before I even touch that level. Any questions on the 45-45? Anybody at home, please ask. Because the next type of triangle is a lot different. Everyone's all right on the rule. Multiply a leg times radical 2 or divide by radical 2 if you have the hypotenuse. Not bad? Sorry if I'm going painstakingly slow here. I got to make sure you guys pick this up. And I know we have a practice day, which is awesome tomorrow. All right, there's the 45-45-90. Now let me introduce you to our next special right triangle. First, I want to start off with, hey kids, anybody want to fill me in on any facts you know about an equilateral triangle? Anybody know anything about an equilateral? I'd love to hear it. 2 facts, actually, I'm looking for. Oh, Gideon.
All sides are 60.
All sides are 60?
I mean, all angles.
So you're telling me all 3 angles are congruent?
Yeah.
Okay, that is correct. All 3 angles congruent. And Gideon went that extra step and said, hey, because they're all congruent, that means they're all 60 degrees. Yes, yes. And what else? I thought actually somebody was going to say this one first. Got me.
All sides congruent?
All 3 sides are congruent. Yes, that's what it means to be equilateral. Perfect, perfect. Remember that now as we go to our first diagram. Remember those facts as we go to our first diagram here. All these triangles are equilateral. Okay, so all the sides are equal. And that means anybody angle A has got to be what? I don't care about C. I'm only going to focus over here. Yep, angle A has got to be 60. All right, keep reading for me. BD bisects angle ABC. Can somebody tell me the measurement of angle ABD now? ABD?
30.
30, half of 60. So let's put a 30 here. All right, so what's the missing angle now in triangle ADB? What's my missing angle? So angle ADB has to be what? Has to be 90 degrees, yes. All right, I am asking you to find AD and side BD now. I will give you a little help to get started. Do you see the 2 triangles you've created by drawing BD in? Do you see the one on the left and the one on the right on your paper? Triangle ABD and triangle CBD. Everyone sees those? Anybody want to? You would be correct. What do I know about those 2 triangles? They are congruent. All right, for multiple reasons. All right, we don't need to go over it, but they are congruent, which would mean what? If the 2 triangles there are congruent, what do I know about AD and DC? If the triangles are congruent, what should I know about segment AD and DC? Okay, I'm going to let you guys go on your own now. You can find AD now. It's equilateral, remember. Equilateral, all 3 sides are equal. And I know those 2 pieces are equal. So go. What's AD? I'll do it with. What's AD have to be then? AD? 1. Hey, AC is 2 because it's all 3 sides are equal. So AB and AC are 2. Divide it up, you get 1. So AD is 1. What can I do to find BD? And what you're going to do? Done. Let's go. Pythagorean theorem. Go ahead. Let's do Pythagorean theorem right now to find BD. Go. See what you got. Hopefully you're using Pythag correctly. Are you? Are you, Caroline?
I think so.
What do you got for BD?
Radical 6.
Where'd that come from? What's your Pythag look like?
2 squared plus 1 squared equals.
A and B are legs.
Oh.
Where you got to put the 2?
It has to equal 2.
Okay, go ahead. Regroup, refresh.
radical of 3.
Darn right it would. Radical 3. Good job. On your own now. Please find AD and BD on the next two triangles. You already know it's a right triangle. We already know AD and DC are congruent. Pythagorean theorem will find BD. Simplest radical form, as usual. Simplest radical form. And then step back and say, hey, is there a pattern there? Is there a pattern? You kids at home, you cooking there? Going along? Keep trucking.
I mean, are these things, I'm just thinking about like in the form of like a particular reason, so aren't these like very case specific?
So I didn't hear a word you
Aren't these
said.
like very case specific, like you need to have an equilateral triangle and you need to have a bisector?
Well, this is, I'm going to get into now. If you see all the triangles we're working with are all 30, 60, and 90. That's what we're going to need. Okay, so I'm not going to give you this. You won't see this diagram every single time. So I'm just going to cut it in half and take off the one triangle, make it a 30, 60, 90. Then all these rules will apply. All right. All right, let's roll. Triangle where the hypotenuse was 4, AB was 4. What did you get for AD and BD? Come on now, come on. Dig deep. Oh, going deep. Emma, second triangle. What did you get for AD?
I got 2.
Darn right you did. And how about BD? Did you get there?
B radical 3. 2 radical 3.
2. You're fine. It's fine. You get nervous sometimes. I know. 2 radical 3. You're good, Emma. Great job. 2 radical 3. Third triangle. Even if you didn't get there, I'm still going to have you do it. Oh, 8 spot. Ryan, back to you today, boss. Come on, time to show off. What was AD?
AD was 3.
3. And BD?
3 radical 3.
3 radical 3. Good work. Oh, hey, kids. We have a little pattern going on here. Yeah? All right. In the previous triangle, it was called the 45, 45, 90. Wild guess what I'm going to call this special triangle? What are the angle measurements in this triangle? 30, 60, 90. So in a 30, 60, 90 triangle, well, we have 2 legs. We have a shorter one and we have a longer one, right? The shorter one's across from 30. Longer one's across from 60. Can anybody explain to me how would you get the longer leg? The one across from 60. Look at your pattern. How could I easily get the side across from 60 very quickly? By doing what? 1 radical 3. 2 radical 3. 3 radical 3. Anybody got a suggestion on how I could find the longer leg pretty quickly?
Multiply the leg by radical 3.
What leg, Maeve?
The like AD. I don't know.
Or okay, nobody's picking that up. Shorter leg. Okay, multiply, yes. Shorter leg times radical 3. Correct. Shorter leg times radical 3. Hypotenuse, kids. How can I find the hypotenuse? Hypotenuse? You got a way. Look at the hypotenuse. 2, 4, 6. Anything I can do with another leg to get to the hypotenuse pretty quickly? Come on now. Come on. Omni.
Multiply the shortest leg by 2.
Shorter leg times 2. Every time. Shorter leg times 2. Good. Good. You're hungry. Good. Any issues? So a lot depends on that shorter leg, huh? A lot depends on it. All right, let's see what you got. It's time to use it now. Okay, find AB and AC. Angle A, these are all right triangles again. So C is my right angle. Take a look. Angle A is 30. I'm telling you, BC is 18. How do I find the other two then? All right, for my first question, I can see I gave you a leg. Which leg did I give you? Is 18 the longer leg or the shorter leg? Look where it's across from. 18, shorter or longer leg? 1-7, let's roll, Maeve. Shorter or longer?
Shorter.
Shorter leg I gave you, Maeve. Stay with me. So, Maeve, if I wanted to find the longer leg, the one across from 60, AC, what's the rule we just went over? What's the pattern? Take your shorter leg and?
Multiply it by radical 3.
Done. All good. Maeve, you're not done. Hypotenuse now, Maeve. What must I have done to the shorter leg to get to the hypotenuse, AB?
Multiply it by 2.
Take your shorter leg, multiply it by 2, and you get the hypotenuse. Okay? Hey, we just got to remember the pattern, right? What do I do with the shorter leg? All right, well, I got a little change up for you. Come on, honors kids, dig deep here. Dig deep. Don't give me this garbage. Oh, I'm home. I can't do this. Nope, let's go. Angle A now is 60, guys. Angle A is 60. And what am I giving you here? BC is 4 radical 3. Uh-oh. 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 All right, you ready? First thing I got to ask, what did I give you? What is 4 radical 3? Shorter leg, longer leg, hypotenuse. What did I give you guys? 2-6. Emma, what did I give you?
Oh, the longer leg.
I gave you the longer leg. All right, Emma, let's sit here and talk because you can handle this. I want to find the shorter leg now, Emma, AC. What was the rule that involved the shorter and the longer leg that you guys just wrote down?
You have to multiply it by radical 3.
Okay, everyone watch. Just watch. You don't have to write all of this, but watch. Shorter leg times radical 3 equals longer leg. 4 radical 3. Everyone agrees? All right, Emma. How would I solve for the shorter leg here then? What would I have to do? With, not multiply by radical 3. What would I have to do with the radical 3 now?
Divide it.
There you go, everyone. See, I know this isn't really mathematical, but it's the best way visually to show you. Shorter leg times radical 3 equals longer leg. So if you want to get the shorter leg by itself, divide by radical 3. And what's the shorter leg end up being here, Emma? Divide both sides by radical 3. They cancel out, and you're left with?
4.
There you go. 4. Oh, you thought you were done, Emma. Not yet. You take care of this whole triangle. Everyone okay on how I got 4? I divided by radical 3 instead of multiplying. All right, Emma, this one's the easier one now. How do you get to the hypotenuse? What's the rule to get to the hypotenuse?
Multiply the shorter leg by 2.
Okay, so what are we multiplying by 2 then?
4.
Good.
2.
4 times 2? 8. And there you go. Good job, Emma. Anybody got else? Anything to say? They want to spout out? This is, I get it. This is not tough. This is why this is awesome this week that we actually have a day to review tomorrow. The way all this fell. All right, last one here before I really throw you for a loop. Angle A is 30. BC is radical 3. What about the other two sides? Uh-oh. All right, who's up with this one? Please not me, please not me, please not me. Oh, yeah, here we go. Sophia, you got this. You ready to just kill this one here, Sophia? Just take over? What did I give you?
Well, you gave us the shorter side.
Oh, that by the way, whenever I give you the shorter side, that is the best. All right, let's go longer leg, Sophia, which would be AC. What must I do with radical 3, the shorter leg, to get to the longer leg?
Multiply it by that.
Okay, so times radical 3. And I know you were watching, Sophia. What happens when I multiply a radical by itself?
It just get a radical.
That one's all good. Hypotenuse. What's the rule? I got to do what to get to the hypotenuse?
The shortest triangle?
Shortest.
Right.
Yep. Which was what for us?
Radical 3.
Take a radical 3 and multiply it by? Okay. 2 times the shorter leg. 2 radical 3. Boom. That's it. Just got to remember. Anything? Ellie, you're right back here in the corner?
Yeah.
All right, still worried about you, even though it's January. We all good? Audrey, you all right up here?
I'm doing very well. How are you?
I'm doing okay. Doing okay. Oh, every day it just saddens me, like, what would the actual class be like?
Probably
Because it's like the A-Day crew's got a personality, the B-Day crew's got a personality. What happens if I bring both of them together? What would happen, What kind of class would we have? What kind of class would we have? That's what I always wonder. And I don't think I'm going to find that answer out this year, but all the things, I love doing during the course of a year, we don't get to do. So
Yeah, I heard Survivor is canceled.
yeah, well, I can't, it'd be kind of tough when some are home, some are here to get votes and stuff, a lot of stuff I couldn't do this year. All right. Last one. Now I'm going to mix the two together. Are you ready for that, huh? Yeah, you are at home. Yeah, you are. Put down the Xbox controller and get ready. Yep. Just because I can't see you, I know what's going on. You know what I'm saying, Dave? You know what your classmates are doing. Little Call of Duty. Yep. Put down the headset so you can hear me. Go ahead. I'll let you guys fill in your own angle measurements here. Go ahead, fill in your measurements and your side lengths so we can talk. The kids don't realize, I don't think, what's going on at home. Let's see, I got a right angle. I got BDC is 45. I got BAC is 30. And I got a 10 spot right here for BC. Good, good, good. Can you guys identify a 45, 45, 90 triangle in that diagram? And at the same time, can you also identify a 30, 60, 90 in that? Yeah, I got both type here. All right, so I'm going to use both rules right now. I'm going to start with the 45, 45, 90 and see if I can fill in the other two sides now, because that's the easier of the two, I feel. All right, who's helping me out here? Yeah, let's see who's up. Oh boy, 1-8. Owen, going back to you. Owen, do you see a 45, 45, 90 in that diagram?
Triangle BCD.
BCD, good job. And do you see I labeled side BC as 10?
Yeah.
Is that side a leg, Owen, or the hypotenuse of that triangle you just gave me?
The leg.
Okay, so since it's 45, 45, Owen, what about the other leg? If one leg's 10 and it's a 45, 45, 90, what do you automatically know about the other leg?
The other leg is 10.
Name it, name it.
CD is 10.
All right, Owen's got one for us, 10. Stay with me, Owen. The hypotenuse is what segment there, Owen? What's the hypotenuse?
BD.
All right, and if you got to look back in your notes, go ahead. What must I do with a leg to get to the hypotenuse, Owen, in a 45, 45?
Multiply it by radical 2.
What's BD then?
10 radical 2.
All right, there you go, Owen. There you go. Nice. I got you specializing in this now. Good job. Any issues with Owen's first two values before I get to the next triangle? All right. Then let's talk the 30, 60, 90 now. There's a 30, 60, 90 in this diagram. Oh boy, 16. Kyla, hello. Do you see a 30, 60, 90 in this diagram?
Triangle BCA.
BCA, good. Kyla, do you know one of the sides in triangle BCA?
BC is 10.
BC is 10. Now, would I consider that the shorter or the longer leg?
The shorter leg because CD is a part of the other leg.
Okay, and it's across from the 30, right? So anything across from the 30 is always the shorter leg. All right, so if that's the shorter leg, what would be the longer leg in that diagram? You're still with me. This is all your problem, Kyla. Keep with me here.
Oh, okay.
It's our-
CA.
CA. All right, from our rules today, what must I do to the shorter leg to find the longer leg in a 30-60?
Multiply it by radical 3.
So CA is going to be 10, radical 3. Nice job. And finally, there's the hypotenuse. What's the hypotenuse in that 30-60, Kyla?
BA.
BA. And what do I do with the shorter leg to get to the hypotenuse in a 30-60?
Multiply by 2 to get 20.
There you go. Any questions from you guys? Not too bad, as long as I know the rules, right? All right, nice big practice day tomorrow. All right, so you can absorb all this and use it on your own without me chatting away. All right, you guys at home, I'll see some of you guys in class tomorrow. You guys here, see you on the screen. Good job, guys. See you tomorrow. Good work. Good work. That was solid right there. Solid.